at FPV Cycle, we've been going through our roadmap of products, and we haven't done anything too revolutionary yet, but we cannot thank everybody more for the support. Just so much, it's been fantastic, and we are moving kind of quickly. We've got a lot of things in the pipeline, a lot of things in development, and every dollar coming into the store is going right back out into development. Our goal is really to make things better, a lot better, and we can't wait to keep going in this direction. But what I want to share right now is, this is one of those videos where I'm just going to kind of talk about my thought process and the train of events that has occurred and things that I've learned about specifically motors here. So I've been working really hard on motors. The 2203 is available, and it's a 2203 for a very specific reason, which I'll get to in this video as well. And I'm making this video now because I've sort of hit a roadblock in my 5-inch motor development. I've been working on a couple of different 5-inch motors and a couple of very different, very new technologies for motors. That's not new to motors, but it's new in our industry. There's no motor like the things that I've been working on in our industry. But I wanted to share kind of some details of things that I've learned from engineers and talking to Ryan Harrell. Massively amazing source of information. He's the guy that runs Mini Quad Test Bench. Highly suggest you read go to his blog, just support him, just everything you can. He's like a pillar of light in our industry for information. So motors are very interesting. They're electromagnets, and the way they function is simple, yet can be very complicated. And in this particular video, so let's back up for a second. I've made a couple videos about motors, and not everything I've discussed has been correct, obviously. I'm just learning. I haven't studied this stuff, and I'm learning specifically from the engineers producing it, and I do a lot of testing of these motors as well. So I kind of wrap all my information that I get with my physical real-world testing and try to figure out what's going on. And this is what I try to create intuition around, and I present here. So everything I discuss in this video is kind of, it's not necessary. It's probably not going to change the way you think about anything, but my goal here is to get everybody thinking about components and thinking about how things work such that they can make a conscious decision which one they want, rather than just picking up the motor that has their favorite pilot's name on it, because who knows how much development actually went into that. So what I'm going to present here are a couple of features of motors and a couple of aspects of particularly the stator volume, magnets, and a couple things that I've discovered that I was very intrigued by. So let's first take a look at this motor. This is the Brother Hobby Avenger 2806.5 Stator, and this is the magnet bell. And what's really special about this motor is that when I flew this motor, the first time I flew this motor, and this is kind of what intrigued me most, because really 5-inch motors from one 2306 to another, they're pretty much all just carbon copies of each other. There's like minor differences in the performance profile, efficiency, and the amount of power output and all that stuff. And it does make a difference overall, but for the most part, a 2306 kind of performs like a 2306, and it's kind of hard to tell the difference between a $15 motor and a $30 motor in flight, in actual flying. It's not that big of a difference, and sometimes the cheaper motors can be better than the more expensive motors because of a certain mix of components that you prefer, and I'll get to that a little bit later in this video as well. So let's first talk about stator and the actual core and how the magnetic metal in the core actually functions to kind of produce the magnetic field. So this is a stator pole here. It's got wires wrapped around it. Electricity goes through the windings, induces a magnetic field. I'm assuming you know this. And then what the magnetic field does is it actually causes all the atoms or the fields, the potential field that can be generated in this magnetic core to be aligned in one direction. And so what happens is the way you saturate a stator is by completely aligning all the potential of the magnetic fields of this pole in one direction. And so once you've produced the maximum magnetic field, the maximum flux that you can get out of this actual iron core, you're not going to get any more, no matter how much more power you kind of pump into this thing. It's just going to be crazy inefficient, and actually the overall magnetic field performance starts going down when the temperature goes up, because things just don't conduct as well as they get hotter. So having hot coils is actually a very bad thing, and for micromotors, I forgot to bring it out here, but micromotors like this 1303, if it starts getting really hot, it's not going to be efficient. And I've actually calculated that on 1106 motors, I actually lose about 40% of the performance after I really push the motor hard and it gets really, really warm. So hot motors are it's just not a good thing. And I'm not talking about hot as in like so hot you can't touch it. I mean, even just warm coils start to degrade the actual performance of the motor. So let's talk about 2306 versus 2207 yet again. So this discussion, which is kind of endless and honestly kind of pointless at this point, but it's a good example of things because they're so similar. So a 2306, which is this one, this is 2306. 2306 stator volume is about 6 or 7% smaller than a 2207. However, a lot of people think that 2306 feels more powerful. And the reason for that is because it's wider than it is tall. Like it's wider than the 22 size motor. And what happens when you make the motor wider is that you shift the torque range lower in the RPM curve. So if you have an RPM if you have an RPM curve that kind of goes up, let's just call it a slanted 45-degree curve. It's not really a curve. As you go up in the RPM range, where the torque is modulated by the width of the motor somewhat. This is a very vague kind of explanation of it. Basically, if you have a wider motor, you kind of push the entire torque range lower in the RPM range. Now, that's arguably a good or a bad thing, but what happens is with a wider motor, you end up moving the torque lower so that in the higher RPM range compared to the taller motor, you don't quite have as much torque, so you're not going to generate quite as much power, and you can't really modulate the prop as well as the taller motor can in the higher RPM range. Now, I just kind of said a whole bunch of things, but it'll make more sense as I move along. So 2306 versus 2207. 2207 will have more torque overall because the stator volume is bigger. You can push more power through it, and you can generate a stronger magnetic field per pole because you have more iron in that pole, and you can generate more magnetic field in that pole, and it takes more. It can consume more power to generate more magnetic field, which is what makes the motor stronger. Plus, because it's taller and it has more stator volume, because it's not as wide as a 23 motor, that torque is higher up in the RPM range. So not only is the motor going to be able to output more power, it's also going to be able to modulate the prop better as it's spinning faster and faster. So the higher end of the RPM, it's physically better to use the 2207 motor for racing, because if you're running higher RPMs, you want to be able to modulate that prop well, and that's what gives you good control feel, and that's what you want when you're racing if you're going really fast. But 23 size motors, or wider motors in general, can make your slower flights or lower RPM range flights feel like they're more in control because you have more torque in the lower end of the throttle. And previously, I'm actually not a huge fan of 23 size motors. I prefer the taller motors, the 2207 motors. However, there's some tidbits about how they function that it's just doesn't work well with flight. It doesn't work as well with flight code if you're not flying super fast. So I have tended to start preferring more 23 and even wider motors because it just seems to work better with the flight code. And previously, I was very annoyed because when you have a 2306 or a 23 size motor versus a 2207, you kind of feel like you zip through the lower end of the RPM range really quickly, and then you kind of just tapers off at the top end. But that's only true if the kV of the motor is just too high. If the motor just can't generate enough torque higher up in the RPM, then it just feels like it tapers off and it's just awful. So basically, you need to have the kV in line for the 2306 to actually function the way you want it to, and then you'll actually get a motor that performs really well. Now, there's a lot of other ways you can deal with that, but let's just skip that and just look at stator volumes and stator heights and widths and talk about that. So as you get taller in the stator, you tend to add more volume than if you go wider. And that is pretty clear. If you do the math, you'll see that as you go wider, you don't actually add a whole lot more volume. As you go taller, you start adding a lot more volume. The problem with going taller on the stator is that you don't create as much surface area as you do volume. So you start adding more and more volume as you go up, but the surface area is comparatively getting a lot smaller. So if you look at like an 1106 motor or 1108 motor, you have this teensy tiny little motor that's got a whole lot of volume and really very little surface area to cool the coils and cool the whole motor in general. So it's going to run very, very hot. So these small 1407s, 1507s, 1607s, 1608s, they're going to be very hot motors. And the problem with heat is that, as I said, it makes the motor very inefficient, and you actually start losing a lot of power out of the motor, a lot of power. You can lose 30% out of a 5-inch motor just because the motor is running hot. And it's not hot to your hand when you hold it, it's hot, like the winds are actually hot. So it doesn't have to be so hot that you can't hold it for you to lose that power. So as you go wider in the motor, and this is one major reason why the 2203 is a 2203, as you go wider in the motor, you have a lot more surface area. And so you look at the stator volume, and while going wider doesn't give you as much volume as going taller, it shifts the overall torque down lower in the RPM range. And if your KV is in check for the size prop that you're planning on using and how you plan to run the motor, then you end up with a motor that has really great torque at the low RPM range. As you go up in RPM, you're going to taper off in torque. But if the motor is not designed for very, very high speeds, that's okay. Or if you just put a bigger prop on it, then you don't really need as much RPM, then you're good. So that's why this motor is a 2203 for a 3-inch Cinewhoop, is because my goal was to get more torque in the lower RPM range, which is where we're typically flying Cinewhoops. We're not typically flying them super quick. So why on earth are we running 1507s and 1608s? We need very good torque in the low RPM range, and that's one of the major reasons why this motor is so smooth. Now the other reason is because the bearing is bigger than a 1507 or 16 whatever, which I'll get to the bearing in a minute, but that's one reason. So not only does the motor cool a lot better, it also has more torque in the lower RPM range, so it can actually modulate the prop much easier, despite it being inside a duct and having all this stuff around it and making it really hard to modulate the prop. This motor has no problem, and it's also fantastic on 4-inch props as well, because typically 4-inch quads, I won't even get to that anymore. Basically, that's one of the main reasons why it's 2203, and then I'll move on and I'll talk about another thing, and we'll discuss why it's so smooth as well. So I hope it makes sense that stator volume is very important, and having more volume in the stator core is how you get a more powerful motor. However, if you're going for a certain performance spec of a motor, then you can play with the overall stator dimensions and get different effects out of the motor. Primarily, or the direction that I've been moving, is that if you go wider instead of taller, you kind of don't have as much volume, but you tend to move that torque in the range that you may use more commonly. So this is a 2806.5. This is a 2803, and the 2803 was primarily going to be my 5-inch motor, and this is the motor I've kind of run into a roadblock on, and I don't know if I'll get to it in this video, but I will discuss it. And it is a very real roadblock, and I've pushed the limits to the point where now I'm beginning to understand why these flat wide motors are designed the way they are. So let's talk about the bearing real quick. So this 2803 has a 12mm bearing, and when I first flew this 2806.5, the Brother Hobby Adventure, I thought that it was the bearing that was making it so darn smooth, because this is a 12mm bearing and it's got a 19x19mm motor mounting pattern, and that actually didn't fit my frames early on. That does actually make the motor a lot smoother, and this Bison motor is a 22.5 size motor with an 11mm bearing and a 16x16 mounting pattern, which is pretty incredible if you ask me. This is a great motor, this Bison motor, but it's also lacking in a couple ways too. So the bearing does actually make it a lot smoother. It makes the resistance, the spinning resistance, much lower to have much bigger bearing in there. And overall, it's quieter. The motor is quieter. And that's another reason why the 2203 is so quiet in the air, because the bearing is bigger. So it's not making all these whiny noises. So that's one thing. Another thing about this motor that makes it so darn smooth is something that I didn't realize at all. I was just trying to mimic that smoothness, and this is something that Ryan Harold pointed out to me, which I thought was very intriguing, and I started looking into more and more. So let's take a look at these two motors, or these two magnet bells. The magnet bell on the right is the Brother Hobby Avenger. The magnet bell on the left is another one of our prototype motors. We have like so many of these at this point, but if you take a look at the magnets on these two, and I'm just showing these two because it's a very drastic difference. So the magnets on these two, the one on the right is not as big or not as wide as the magnets on the motor on the left. And so what this does is having wider magnets and smaller gaps between the magnets increases the amount of magnet space to intermagnet space. So basically more of the ring is magnets and less of the ring is just empty space between the magnets. And so if you look at a smaller motor, here's a 2306 compared to the Brother Hobby Avenger motor, the 28 size motor, yeah, those magnets on the 28 size motor are much wider. And so what that means is that as the motor is spinning, the stator and the ESC has more time with magnets in effect than magnets not in effect. Now you can't have the magnets be totally smashed up against each other because it runs into a number of problems. I'm not going to get to that in this video, but I'm just presenting a couple of interesting concepts to consider. I will discuss the issues with the 2803 and the reasons why the motors don't work the way they do and why they're supposed to be made the way they are. But basically what I'm presenting here is that if you have a motor that has more magnet versus intermagnet space, the ratio, you tend to get a motor that runs a lot smoother. So the reasons why this 2806.5 are so smooth is not only because it's generating a whole lot of torque, it also has a massive bearing, and it also has a better magnet to intermagnet space ratio, which is all together going to give you a motor that runs a whole lot smoother. So 2806 size motors just are super smooth. And this one, this prototype that we have, it just runs so silky smooth and so nice to fly that it's intoxicating. It's unfortunate that this particular, where's the stator for this? I didn't bring the stator for this out here. I don't know where, oh, here it is. Here's the stator for this. This one's a little bit wonky. It's kind of like a super prototype. It's got like a 9mm bearing. All of this is metal. And so this is the other thing I want to point out. So going back to stator volume, if you take a look at this motor and this motor, the overall stator, the overall poles are very similar in length, and the overall ferrous material is very similar as well. But if you look at the aluminum that's surrounding the Brother Hobby stator, it's much thinner than the aluminum that's surrounding this prototype stator. And so, yeah, sure, this is going to be stronger, but you really don't need that much aluminum. But what I'm trying to show here is that there's different ways you can design this stator. Because there's so much aluminum around this bearing, they could have made the stator design such that the poles were longer, maybe a little bit longer, such that you had more iron or more ferrous material in the core, and you could potentially generate a stronger magnetic field. So if you look at I can't take apart Rcinpower motors. They're so annoying to get apart. You have to like hammer them to get them apart, so I can't show you. But if you look at the stator poles on this 22.5 versus this 2306, it's hard to see, but because this one's got an 11mm bearing in it, the stator is just genuinely different. They redesigned the stator so that it has shorter poles. And so you just have less iron in the stator core. So you're giving up some overall volume for this larger bearing. And so to get an accurate read on the actual volume that's in the core, you kind of need to subtract the bearing space and also this aluminum surrounding space to get an accurate volume measurement for how much stator you're actually going to have in there. So comparing from one 2306 to another 2306, or even 2207 to another 2306, it's really hard to gauge which one is actually going to give you more power, more performance, because you genuinely have different volume cores. So you just can't tell unless you actually look at the motor, inspect it, and see how it's constructed, and put the numbers together and figure out, okay, this one should perform this certain way, and this one should perform this other certain way. So the reason why this Wasp motor is a 22.6 by 6.5 is because the goal with this Wasp motor for Rcinpower was to produce as much power in a motor that's as light as possible. And it just so happened that 22.6 and 6.5 height gives the optimal volume space for the stator with the way they've designed it and this 9mm bearing for them to get this kind of performance profile out of it. Now, I haven't talked about magnets or anything else in this video. It's been long enough, but basically the basic concept of this video, what I'm trying to convey here is that, first of all, stator volume is very important. Second of all, the overall size of the stator can be very influential to how the performance of the motor is produced. And third, there are a couple of things, a couple of tricks that could be done with magnets and overall stator designs, such that you can kind of fill in the gaps between magnets and make the bell feel very smooth. And I haven't talked about this. I mean, I can't even believe I spoke so long about just the stator core, but basically there's a lot more to all of this. And the way to design a motor to get the certain performance profile that you want, there's a lot of components to think about, and there's a lot of things that you can work with to try and get the actual results that you want. It's just that this stuff just isn't explained and discussed. So like when I do finally finish the 5-inch motor, I'll kind of show you, and I'll show everybody why it is the way it is, why the whole design and everything is how it's actually intended to be for the specific performance profile that I'm aiming for. I hope this was helpful. I hope I wasn't just ramble on forever about something that you may not have cared about, but basically things matter. And yeah, stay tuned for lots more. Bye.